Hello, mathematicians. Today we're going to be learning about slope-intercept form, and more specifically, positive slopes. So if you recall from our savings video, I had $50 already saved up, and every week after that, I added $20 to my savings. And Mr. Morano started off with $100, and every week after that, he added $10 to his savings. So here I have my table and I have my graph. So on my graph, you'll notice that I started counting by 20s, so 0, 20, 40, 60, and so on for my y-axis, and for my x-axis, I counted by ones. So because I started off with $50, that's directly in between 40 and 60, so my $50 would be here. And every week after that, we added $20. So here after the first week, it would be at 70, then it would be at 90, 110, and so on. Now this one is a little bit harder to see just because I don't have my line on an exact point. It's in between numbers for my y-axis. But because it's counting by 20s and because it's directly in the middle, we could use our table, or we could just estimate just by looking at our graph. In this case, it's exactly 70, but that's not always the case when this line intersects. So here I have Mr. Morano's table and his graph. Now he started with $100, and that is on my y-axis, so $100 would be plotted here. So before any weeks have gone by, he would have $100, and then afterwards he would add 10 at a time. So after the first week he would have 110, and because I counted by 20s, 110 lies in between 100 and 120. And then after 2 weeks, he has 120, and this is an exact point on our graph that's easy for us to look at. And then after 3 weeks, he would have 130. And now that's hard to see on our graph, but because it's in between, we could estimate if we are not sure, but in this case, we have our table to tell us for sure. And then at 4 weeks, he would have $140. So there are some exact points on our graph that make it a little bit easy for us to see. So here I have both my graph of my savings and his graph of his savings. And what I'm going to do is I'm going to put them directly on top of each other to see what happens. So if you put them directly on top of each other, you'll notice that the purple is me. And I started off with less money than Mr. Morano, but as time went by, I actually started saving more because I had put in $20 per week. And so if you look at the purple line, I have less, I have less, I have less, and then all of a sudden on week 5, our lines intersect over here. And when they intersect, that means at this point, so at 5 weeks, we have saved the same amount of money. Okay, so at 5 weeks, we would both have $150. So here we see the number of weeks, and if we look to the side, it's directly in between 140 and 160, so that's $150. So at 5 weeks, we would have $150. So I'm going to talk a little bit more about that. So if we look at mine, which is the purple line, okay, we have the X down here, which is the number of weeks, and we have the Y here, which is the amount of money saved. And if I wanted to represent how much money I have saved, so my Y, I would write out the amount that I have and the amount that I'm saving per week. So per week, I'm saving $20 per week. And since I'm not sure the number of weeks, I'm going to put X, so $20 per week, plus the amount I already have saved, which is $50. And in Mr. Morano's case, if we want to know the total amount of money, he saves $10 per week, and he has $100 already saved up. So these are two equations that I could use. So the X represents the number of weeks, and the Y represents the total amount of money we have saved. So for example, if I wanted to know after, let's use 5. So if I wanted to know the amount of money I have after 5 weeks, I would simply substitute 5 for X, and I would have 100 plus 50, which equals 150, and that's our point on the graph. And then if I wanted to know after 5 weeks for Mr. Morano, I would put Y equals 10, substitute for 5 plus 100. It would be Y equals to 50 plus 100, which is also 150. So I can certainly use my two equations to find out how much money we have saved for any point in time. And if you know the amount of money you have saved, you could also use it to find the number of weeks you saved. So for example, let's say I know I saved $150, but I didn't know how long it took. So I would substitute the Y, and instead of writing Y, I would write 150. So directly underneath, I'm going to put 150 equals to 20x plus 50. And if I wanted to know how long it took to save $50, I would simply solve for x. So minus 50 minus 50. Those are inverse operations, so it cancels out. 150 minus 50 is 100, is equal to 20x. I want to isolate my x, so I'm going to divide both sides by 20. And 50 is equal to x. Sorry, 5 is equal to x, meaning that after 5 weeks, you would have $150. So I'm going to just rewrite my two equations again. So I had y equals to 20x plus 50. And I have y is equal to 10x plus 100. And now with these two equations, if I want to know when we'd have the same amount, that would mean that our savings, y, would be the same. So if y would be the same, then that would make these two equal to each other. And then in that case, we would have 20x plus 50 is equal to 10x plus 100. So again, you would solve for x. So I want to get all my numbers on one side and all my variables on the other side. So 10x is equal to 50. And if you divide both sides by 10, x is equal to 5, which is the number of weeks that it would take for us to have the same amount. So the reason why x is only equal to 5 is because this is the only point in time where we'd have the same amount of money saved up. Because after that, then I would have more money saved up than he would. And looking at our two equations again, so looking just at this one, our 20 is how much we save per week. So $20 per week, which is a rate. And in this case, it's actually a unit rate, but it doesn't have to be a unit rate to be here. So this is a rate. And here, our 50 is our initial value, because that's how much we started off with. Okay, so that's for the purple line. And for the red line, our 10 represents $10 per week, which is our rate. And our 100 represents our initial value because it's the amount we started with. So I use the words rate and initial value because those are two words that you should be familiar with. But we're going to call it slope and intercept, and I'll show you guys why. So slope is the same thing as a rate. So our rate of change. And our y-intercept is the same as our initial value. And I'm going to show you what this means. So our slope here says rise over run. And on a graph, I'm going to show you that. So I'm going to clear this. And I'm going to put this graph back here. And I'm going to use this red one to show you what rise over run means, okay? So I'm going to put my points on exact coordinates. And what the slope is, by looking at our graph, is we're going to take two coordinates and we're going to see how much we rise and how much we run. So even though this is one square, it represents $20. And this is two squares, and each one represents 1 week, so this is 2 weeks. And so here we have our rate. So we have $20 in 2 weeks. And this one is Mr. Morano's. And I'll take this one out to avoid the confusion. So here From this point to this point, we rose $20 and we went over 2 weeks. So this is our rise and our run. So $20 in 2 weeks. So this rate is equal to $10 per week, which is what we talked about when we had y is equal to 10x plus 100. These two rates are equivalent. So our slope could be found by using any rate on our graph. So I'll show you guys another example. If I didn't want to use these two coordinates, I could use any two coordinates to find my slope, which is my rate of change. And in this case, here we went up 2 units, which from 120 to 160, that's $40. And here I went over 4 spaces, so that's 4 weeks. And $40 in 4 weeks is still equivalent to $10 per week, which is our slope. So our slope is just the rate that our graph is changing by. Our y-intercept is our initial value where we start. So our y-intercept is also called y-intercept because it intercepts the y-axis. So here at 0 weeks, Mr. Morano has $100. So at this point. And here, if we look at the definition, y-intercept is where the line crosses the y-axis. And when it does cross the y-axis, x is always going to be 0. So if we look at our graph, x is 0 and y is 100. So our x is always going to be 0, but our y is going to change. So here I have another problem. It says Joe's plant is 4 centimeters tall, and his plant is already 4 centimeters tall, so that is what I'm going to start off with. That's my initial value, which is also called our y-intercept. So I'm going to plot on 4 centimeters, and his plant grows half a centimeter per week. So in 1 week it grows half a centimeter, and then I'll actually make a table. So weeks, which is our x value, and centimeters, which is our y value. So the plant is already 4 centimeters, so before any time passes, it's 4 centimeters. After 1 week, it's going to grow half a centimeter, so 4.5. After 2 weeks, it's going to grow another half a centimeter. So if you notice here, our y keeps increasing by 0.5. Then it'll be at 5. And then after 3 weeks, 5.5, and 4 weeks, 6, and we could keep going if we wanted to. So what I'm going to do is I'm actually going to pick the points that I want to graph that are easier. So 0, 4, that's easy. 2, 5, that's easy to plot, and 4, 6 is easy to plot. So I already have 0, 4 plotted, 2, 5, and 4, 6. So what's going to happen is when I do connect these, I'm going to just extend my line with an arrow at the end to show that the plant could keep growing. If we look at our line, we'll notice that even though I did not plot 1, 4.5, it's still here and it's still represented by our line. And even though I didn't plot 3, 5.5, it's still here. So by plotting the points that we felt were easier within this table and drawing our line through it, we're still including all the values in between. It just makes it a little bit easier to graph. Now, if I look at this graph by itself without any information, I could simply look at the y-axis and see that our y-intercept is 4 because that's where our line crosses the y-axis. So our y-intercept is 0, 4. And what this means is before any weeks pass by, so at 0 weeks, the plant is 4 centimeters. Now, looking at our graph still, if I drew a triangle using these 2 points, that's my rise and this is my run, I could see that from 5 to 6 it increases 1. And then from here, from 2 to 4, it goes over 2. So here my rise, so I'm going to write my slope. My rise, the amount it goes up is 1, and my run is 2. So my slope in this case is 1 over 2, which is the same thing as half a centimeter. So to write this in slope-intercept form, we would write y equals 1 over 2 x plus 4. The 1 over 2 represents half a centimeter per week, and the 4 represents the initial value, which is how tall the plant already is. Here we have Jenna has 4 flowers and plans to plant 2 every 5 days. So she already has 4 flowers, so that's what I'm going to start off with. So before any days passed, she has 4 and plans to plant 2 every 5 days. So what I'm going to do is I'm going to write days, and that's our x, and flowers, well, the number of flowers is our y. And before any days pass, Jenna already has 4 flowers. After 1 day, she wouldn't really have a flower because every 2 days she plants 2 flowers every 5 days. So what we could actually do is we could count by the days. So after 5 days, she planted 2. And then after 5 more days, which is at 10, she planted 2 more. Sorry, I wrote that wrong. She planted 2 more, which is 6. After another 5 days, she planted 2 more, which is 8. After another 5 days, she planted 2 more, which is 10, and we could keep going if we'd like to. So here I have our start value, and then my next point is going to be 5, 6, because after 5 days, she will have 6 plants, because she planted 2 more and she started off with 4. And then after 10 days, she'll have a total of 8 plants. And I'm going to try my best to draw a straight line here. and draw an arrow at the end. And again, let's say we were not given this table. Our y-intercept is our initial value. So at 0 days before Jenna even does anything, she has 4 plants. So our y-intercept is 0, 4, because at 0 days she already has 4 plants. And our slope we could find by drawing our triangle. So my rise and my run. And from here to here, rise is 2. And our run is 1, 2, 3, 4, 5. So our slope is 2 over 5. And if we didn't have this problem to tell us verbally, we would write y equals 2 over 5x, representing 2 plants every 5 days, plus 4 representing our initial value, so the number of plants we already have. Well, Jenna already has. And that's it.